This presentation provides an overview of the next generation microinverter, its features and advantages. Enphase introduced its first generation microinverter technology in June of 2008 with a CEC efficiency of 94% and a power output of 175 watts. Approximately a year after introducing our first generation technology, we introduced the second generation with an efficiency of 95% and an output of 190 watts. Efficiency, power, and installation are the areas we continue to focus on as we reached our third generation platform, the M215. At 215 watts AC, this microinverter has 13% higher output than the M190 or D380. The higher output power means that Enphase microinverters pair with even the highest power 60-cell modules, such as the 250 watt and 260 watt modules becoming more available this year. Enphase was able to achieve the higher power output through a completely new inverter architecture which uses a variety of custom developed components with an ultra-low profile. This has also allowed us to get to a 1-inch thickness, which reduces the size and weight of the product and improves our thermal performance by providing a higher surface area to volume ratio. So again, we're talking about using higher power modules, 60-cell, mono or polycrystalline, up to 260 watts. Your customers will like that they can get the cutting-edge module and inverter technology, which reduces roof space and installed cost. 96% CEC efficiency. Yes, that's right, 96%. At 96%, we are on par with the top string and central inverter efficiencies. It's important to note that this is a weighted efficiency rather than peak. Our efficiency level over our power range is extremely flat, meaning that performance at low light conditions is equally efficient as during normal times. Enphase is the only company that can claim this. Probably the most significant achievement of Enphase's third generation technology is its new microchip core. I know most companies in solar don't talk about chips, but Enphase is unique among inverter companies in that our electronics are based on a fully digital control architecture. This means that we're developing application-specific integrated circuits, commonly called ASICs or custom chips, to operate our inverters. In our new microinverter, we are introducing an ASIC that leverages a system-on-a-chip design, meaning that we've developed multiple sections in the chip that help us precisely analyze, predict, and control the flow of power through the electronics. This makes our response times to changing input power extremely quick and precise, ensuring that not even one electron is lost. As a result, our conversion efficiency and MPPT efficiency are extremely high with this chip. We're at 96% conversion efficiency with a maximum power point tracking efficiency of 99.8 static and 99.9% dynamic. One other compelling aspect of our digital control is that it enables very high conversion efficiency at low power levels. Thanks to a unique capability called burst mode, there is no drop-off in efficiency as the input power decreases below 20%, which is unique among inverters. This means that the performance at low light conditions is highly efficient. In addition, the next generation microinverter introduces a low voltage operation capability, where it will continue operating even down to 16 volts of DC input. This is actually below the standard operating voltage of a 60-cell module, which is typically 22 to 36 volts. And you only get below 22 volts if an entire substring within the module is shut down due to abnormal shading patterns. The ability to efficiently convert such low DC voltages is completely unique to Enphase microinverters. Lastly, we're reducing the size and weight of our inverters, which also allows us to innovate the handling and install process for greater efficiency and cost savings. Specifically, we've taken an entire pound off the inverter, which allows us to use a single mounting bolt. We designed it to be a flush mount and added a wire channel to make installing the grounding wire easier. And as you may have noticed, we created a next generation cabling system that basically combines the simplicity of the M190 cabling with the cost savings of the D380 cabling. Now let's take a closer look at the cabling. Our inspiration in developing this cabling was to create a true bus cable. It offers a large 12-gauge conductor to function in larger 20-amp circuits, while also enabling complete design flexibility. The cable is a continuous length with built-in connectors. It's either a 4 or 5 conductor cable, depending on if it's a split-phase cable or a 3-phase cable. This means 4.3 kilowatts on one 240-volt branch circuit, assuming you're using 250-watt modules, and 6.5 kilowatts on one 208-volt branch circuit. In addition, a 20-amp branch nicely matches the 120% rule for feeding the bus bar. In addition to the capacity of the branch, we've made installing branches simpler and faster. There's 2 different spacings of connectors for portrait and landscape. You cut the cable to length, that's right, you cut the cable, then splice one end into a junction box. The other end is terminated using our termination cap. If you need to skip a connector to get more length, there are watertight caps to seal the unused connectors, or if you need to run the wiring through conduit to another subarray, there's a splice kit that allows you to splice with standard THWN Type 2. Alright, now that you've heard about the M215, let's take a quick look at how it compares to our current products. In terms of performance, there's no question that the M215 delivers. Not only does it have higher efficiency, but it also has improved MPPT efficiency and that low voltage support. In addition, the M215 is a great match for the leading-edge, high-power 60-cell modules coming more into the market this year. That being said, the M215 is not compatible with 72-cell modules because the voltage can be too high. Now, damage may occur if you connect the M215 to these modules. We stole the best parts of our second-generation platform and combined them into a single product that is more powerful and more efficient. We took the simplicity and flexibility of the M190, one inverter to one module, and we took the balance of system cost reduction of the D380, fewer bolts, lighter weight, 20-amp branch circuits. Thanks for viewing this overview of Enphase's third-generation M215 microinverter. And please see the other on-demand modules to get more detailed technical information on the M215.